Okay, so we're going to start by graphing this graph that has a horizontal phase shift. So right here we can see that we have negative 3 pi over 4. So that means that h equals 3 pi over 4, which means that we're going to have to add that to all of the x coordinates. So let's first do the regular sine function. So at 0 degrees, sine is 0. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, sine is negative 1. And at 2 pi, sine is back to 0. So now we're going to do it with the phase shift. So y is staying the same, but for every x we're going to add 3 pi over 4. So every angle add 3 pi over 4. So this is where we get fancy with fractions. Okay, 0 plus 3 pi over 4 is just 3 pi over 4. Pi over 2 plus 3 pi over 4. So pi over 2 is like 2 pi over 4. So plus 3 pi over 4 makes 5 pi over 4. And then I have pi plus 3 pi over 4. So that's like 4 pi over 4 plus 3 pi over 4. So 7 pi over 4. Some of you may notice the pattern here, 3, 5, 7. The next one's obviously going to be 9 pi over 4. And the last one, you guessed it, 11 pi over 4. Okay. Now for y, nothing changes. So 0, 1, 0, negative 1, 0. Okay, now we have to graph it. So 3 pi over 4 is just pi over 4 less than pi. That's 45 degrees less than pi. So that would be the point right here. 5 pi over 4 is 45 degrees past pi. So we want that right here. 7 pi over 4 is just shy of 2 pi, because that would be 8 pi over 4. So now we're back to 0. And 9 pi over 4 is 45 degrees beyond 360, so that would be right here. And then 11 pi over 4, we're back to 0 again, so right here. And then you can draw your, okay, this is going to be ugly. Ooh, better than I thought it was going to go. Alrighty, so that's your only real example for phase shift and vertical shift. Vertical shift is like way easier. You keep all the x's the same, and then you just add or subtract anything to the y. And then if you have to do both, then you just do them separately. Okay. So let's look at another example, the next one down on your notes. I'm just going to have to erase everything here. Okay, so give an equation for sine and an equation for cosine for the wave graphed on the right. All right, so let's start with sine. So when we're doing sine, we're always looking for that point, and I can see it right, I'm probably going to miss it, but oh yeah, I missed it. It's right there-ish. Okay. And that means that it has shifted over. It's somewhere between pi over 4, which is 45 degrees, and pi over 2, which is 90 degrees. So it's halfway there, and probably 60, but you can verify that by going, okay, this is pi over 4, pi over 2 would be 2 pi over 4, so it's 1.5 pi over 4, which is the same as saying 3 pi over 8. So that's a phase shift of 3 pi over 8. Okay, now The other thing we have to look for is the amplitude, which is b. Right now, the distance between the peak and the lowest point is 4, and half of that is 2. So normally the maximum, since the amplitude is 2, would be on 2, and right now it's down to 0, so that means that k is -2. Oops, -2. That's a phase shift of down 2. And the last thing we have to worry about is A. And we find A by knowing what the period is. So it's good to like look at 2 points. So right now I can see that there's a repeating point right here and right here. Darn it, I missed it again. Okay. And that was... I lost my picture. Okay. So we just said that we have a distance of 0 to pi over 2 for our period. So that means that you know what your period, so pi over 2 is 2 pi times A. Okay. And so we can say that the pi's cancel. So we have 1/2 equals 2a. So when I move this 2 to the bottom, I get 1/4 equals a. Okay, now I can graph it using signs. So y minus k, so plus 2 over b. Oh, shoot, I forgot to write that right here. Sorry. Okay, over b equals sine. And then we have theta minus h, so minus 3 pi over 8 over a, 1/4. Beauty. Okay. Now let's do this for sine. So hopefully, like, pause it, copy that if you need to. I have to erase some of this for space. I'm sorry, we're going to do it for cosine now. So there's some stuff we can keep, like a and b and k, but h is going to be different. So Okay, so let's talk about h for a second. Let me try to redraw that. All right, not bad. Doing all this with my finger. BT dubs. All right, so, okay, if it's cosine, the point we look for is this peak point. I'm just going to erase this. So this peak point right here didn't budge at all. So that means that h equals 0. So when I go to write the equation, I can just go y plus 2 over 2 equals cosine, and then I have theta over 1/4. That was a little ugly. Okay, so hopefully that helps you out. Pause that if you need to copy it down, because we're moving on to the last example here. Okay, so let me grab my last one. Okay, determine how many solutions each equation below has over the interval of 0 to 2 pi. So what we're talking about here first is cosine of 3x. Now in this situation, we can say that a is 1/3, because remember that we have to factor it out and put it underneath the x. So what that does is that is a horizontal compression by 1/3. Okay, so now the period, don't forget, is 2 pi times a. So it would be 2 pi times 1/3, which is over 3. Kind of ugly. All right, so Now that we know that it's 2 pi over 3, we know that there will be more periods than regular between 0 and 2 pi. And actually, the trick is that if a is 1/3, that means that there's 3 times more periods. So let's look here. So if I have 2 pi over 3. So this would be 1 pi over 3, 2 pi over 3, 3 pi over 3. Oops, I'm going about this the wrong way. Let me just, sorry. Okay, let's just say we have 2 pi here. So because a is 1/3, that means that we have three periods between 0 and 2 pi. So 1, 2, 3. And we want to know how many times does this equal 0.8. So if I drew 0.8, that's like right across here. And that happens 1, 2, 3, 4, 5, 6 times. So my answer is 6. Okay, let's look at sine for a second here. So when you have this one, I'm just going to take this 5 and put it to the other side, so don't worry about it. Okay, now in this case, we're saying that a is 2. So that's going to stretch it out. So we're only going to have half of a period between 0 and 2 pi instead of a full one. So here's, so normally sine would do this, but now we're stretching it out, so it's going to do this. And if we think about that line, just picking random colors here, or -3 over 5 is down here. And between 0 and 2 pi, that never happens. So it never crosses that line. So our answer is 0.